Okay, today's test review focuses on rational numbers versus irrational numbers. And you do have pages in your interactive math journal that show you rational numbers versus irrational numbers and how to change repeating decimals into fractions. So if you're having any troubles at all, use your interactive math journal to help you out. So my first reminder is that rational numbers can be made into fractions. So for example, 1.2, which I read as 1 and 2/10, is the fraction 1 and 2/10. So that's a fraction. That has to be a rational number. Square root of 4, which is equal to 2, that could be written as a fraction 2 over 1. 1.13 repeating, I can make that into a fraction by setting x equal to the repeating part, so x equal to 0.13131313. And then since there's 2 digits in the repeating part, and I want the decimal to be after those 2 digits to the right of it, I have to multiply by 100 because 100 will move the decimal twice. When I multiply x by 100, I get 100x. When I multiply 0.13131313 infinitely by 100, I get 13.1313 ... Now I have to subtract x on both sides. So over here I subtract x. Over here I subtract what x was equal to. X was equal to 0.1313. So over here I'm minusing 0.1313 ... On this side, if you do 13.1313 minus 0.1313, you're going to get 13. On this side, if you do 100x, take away x, you're going to get 99x. Now I have to divide on both sides by 99, and that's going to give me x equals 13/99. Now I can't forget that it was 1 and 0.131313, so then it's going to be 1 and 13/99. Alright, so now you're going to write which of these are rational, and I'm going to pause for just a minute because there will be a question asked to you and you're going to answer the question. Okay, my second reminder is that irrational numbers cannot be made into fractions. You can't make them fractions. You can't make them fractions because, number one, they never end. They just keep going on and on. It might look like they end on your calculator, but that's only because your calculator runs out of room. And not only do they never end, but they don't repeat either. So some examples of irrational numbers are the square root of 7, the opposite of the square root of 11, and pi. You cannot make these numbers into fractions because they keep going on and on and on, but there's no pattern to how they keep going on and on. To change a fraction to a decimal, you're going to divide the numerator by the denominator. So for instance, if I give you 1/2, you should know that 1/2 is 0.5. But if you wanted to use your calculator, 1 divided by 2 gives you 0.5. Numerator divided by denominator. Okay, now you're going to change each of these fractions into a decimal, and there's going to be a question that you have to answer again, so I'm going to pause. Okay, to change a decimal to a fraction, the first easiest way is just to read it with its value. So for instance, 1.01, when you read it with its value, is 1 and 1/100th. 1 and 1/100ths. And so then that means the fraction is going to be 1 and 1/100ths. If I gave you the fraction 3.602, you'd read that 3 and 602 thousandths. So that would be 3 and 602 thousandths. Another way that you can write a decimal as a fraction is using the set it equal to x method that I showed you earlier. And you also have this in your interactive math journal. So here, the 0.2 is the repeating part, so I set x equal to the repeating part. Then I need the decimal to move one place because it's just the 2 that's repeating, so I'm going to multiply this by 10 and this by 10. It's going to give me 10x equals 2.222 dot 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 dot. And then I'm going to subtract an x here and subtract what x is equal to over here. So 0.22. And if you do 2.22 minus 0.22, you're going to get 2. This 2 is all that's left. And if you do 10x, take away x, you're going to get 9x. So now you have to divide by 9 on this side to get rid of the 9, and divide by 9 on this side, and x is equal to 2/9. Now I can't forget this 2 because it was part of the problem in the first place. So my answer is going to be 2/9 plus 2, which would be 2 and 2/9. Now you're going to be changing these decimals into a fraction. And I'm going to pause again. Okay, to justify whether a number is rational or irrational, use your calculator and then explain how what your calculator shows means whether it's rational or irrational. So my example I'm giving you is the cube root of 25. If you used your calculator to find the cube root of 25, it would give you 2.92401773821, and if it had more room, it would give you more numbers here. So based on this, I can see that it's not ending, it's not repeating, and so it's irrational because it doesn't repeat or terminate. So I showed what my calculator had, and I explained that that means that it's an irrational number because it doesn't repeat or terminate. Now you're going to be doing this for 4A, 4B, and 4C. Okay, you are done with your homework and you only have one night left. Be sure to review things that gave you any trouble at all, because again, we're reviewing things for the test and you have your test on Friday. Have a good night, you guys.